forces, yay! We're going to start talking about Newton's laws of motion. And, you know, really they should be called Newton's laws of forces, but hey. So Newton's laws. Today I want to introduce Newton's first law. And this is something, oh, let's go first. There we go. Newton's first law. You've probably heard of it before. It's often called the law of inertia. And so if we're talking about the law of inertia, what does that mean? When you think of the word inertia, you probably think of something heavy. It's got a lot of inertia. Or like when you have a really big car and it wants to go down the slope, it's hard to stop because it has a lot of inertia. And that's pretty close to what the law is about. The way we typically talk about it is an object in motion stays in motion. Object at rest stays at rest. So let's do this. An object in motion or an object at rest stays in motion, or it stays at rest, but that's not the whole thing. The important part of this law is the last bit. An object at rest stays at rest unless acted upon by an outside force. So there is Newton's first law. An outside law. Let's try the right word. An outside force. There we go. And so an object in motion stays in motion unless acted upon by an outside force. An object at rest stays at rest unless acted upon by an outside force. You have experience with this. We all do. You want to go explore, do a little experiment? You might want to do this someplace that can get wet, like outside, a bathroom, kitchen floor. Don't do it in a carpeted area. Go get a mug or a bowl, fill it full to the top with water, and then try to cross the room as quickly as you can without spilling anything. Go try it. That's Newton's first law. Go, hit pause, do it. Okay, did you do it? You probably made a mess. As quickly as you can, try to cross a room with a full cup or bowl of water. You probably made a mess. So when you start with that, you started moving, whoosh, what happened? Which way did the water which way did it move? The water went this way. Because that water is like, water's here. If you ignore the cup or the bowl, the water is a little mass right here, and the bowl is saying, oh, I'm going to move you this way. And the water says, I don't want to move, I'm going to stay right here. And so some of the water goes, bloop, and it feels like it's falling backwards, but really it's staying in the same place. And that's just one example. An object at rest stays at rest. So the water was at rest, it wants to stay at rest. And an object that's just at rest, boop, it's pretty clear. Unless something acts on this, it's not going anywhere. You know, it's even more clear if I just said it like that. That could sit, unless there's outside force, that would sit there for the rest of time. All right. An object in motion stays in motion unless acted on by an outside force. This is a little more difficult because we don't often see objects in motion without outside forces, because everything we have around us has at least one force on it. The force of gravity, the earth pulling down on us. And so this one's a little bit harder, but the idea is that if you have something, a cart, and it's moving along at some velocity, if there are no outside forces in this direction, it would just keep moving along at that velocity forever until acted on by an outside force. If there's no air resistance, if there's no friction, there's no pushes or pulls, there's no reason that it would speed up or slow down. I mean, why do things slow down? You push a chair and it slows down. So that's probably part of your brain saying, well, wait a minute, where's the force? Think about what that chair is interacting with. The earth, gravity pulling it down, the ground supporting it, the normal force, and what's the third force that acts on a chair when it's moving? Friction. And that's what slows something down. We have an unbalanced force there. And so this is Newton's first law. There's lots of fun demos about Newton's first law, and it's something I just want you to keep in mind. We don't use it that much when we're problem solving because it's kind of built into the other two laws that we're going to be talking about. And so this is just real quick, Newton's first law. There we go.